Hello everyone. So today we are going to learn about introduction to CLIP. CLIP stands for Contrastive Language-Image Pretraining. So what is CLIP? CLIP is a model created by OpenAI and its name stands for Contrastive Language-Image Pretraining. It works by connecting images with their text description in a shared space. So the computer can understand both pictures and work together. So by training on a huge variety of image and text pairs, CLIP becomes very flexible. This flexibility lets us perform many tasks like recognizing objects in an image without any extra training, a technique known as zero-shot classification. So motivation behind CLIP is training models need large level of data set for each task, which can be expensive and time consuming to create. So they also struggle to handle new and unseen tasks because they are trained for very specific situations. CLIP tackles this problem while learning from a huge and the varied collection of image and text pairs. So instead of relying on carefully labeled example, it uses natural language descriptor as a guide. This approach allows CLIP to work on many different tasks right away, making it more flexible and broadly useful than other models. So has two main parts. First is the image encoder, which could be convolutional neural network like ResNet, or a vision transformer, that is VIT. It takes an image and turn into a set of visual feature. Second, it is the text encoder, which is the transformer based model similar to ChatGPT or a Word. So it converts text into a matching set of features. Both set of features end up in a same high dimensional space, so that images and their related text end up close together, making it easier for a CLIP to link pictures with their description. So in this approach, you can see CLIP training and uses can be split into three main parts. CLIP's training and its users can be split into three different steps. That is, first is contrastive learning, contrastive pre-training. So the model sees many image text pairs. If an image and a text match, it pulls their embedding close together. So if they don't match, it pushes them apart. This teaches CLIP to link image with their right description. So creating a classifier from label text instead of needing a labeled example, we simplify a text prompt like a photo of a dog and turn them into text embedding. So zero-shot classification is to classify a new image CLIP. CLIP compares the image and the embedding of a label prompt and picks the closest match. This way, it can recognize object without any extra training. So CLIP uses contrastive laws to teach the model which image matches with which text. So which images matches which text. So during training, a model compares all image and image embedding with their text embedding by calculating their dot product. So these scores are then turned into probabilities using a softmax function, and the model learns to assign high probability to correct image text pairs and low probability to mismatched pairs. So this contrastive approach makes CLIP good at understanding how picture and word go together. So CLIP is trained on a massive collection of 400 million images and their captions gathered from the internet, because these captions come from everyday sources rather than the spatial labels. So the model learns to handle a wide variety of visual concepts without needing extra manual labeling. So this large diverse data set makes CLIP highly adaptable and ready to work on many different tasks right away. So how CLIP perform zero shot? right? So Clip can classify images with their extra training by treating class labels as text prompt. So for example, if you want to check whether an image, so a cat, or you use a text prompt like a photo of a cat, so Clip convert both the image and the text prompt into a numeric embedding and compares them. So whichever text prompt is closest to the image embedding becomes the predicted labels. So this allow Clip to handle image classification across many different categories, uh, all without having to train on each new task separately. So there are some of the application also. So if we use it for the image classification task, uh, without specific training, also for the robust performance across domain. So this is the data set that we have created for the newer task, and I have adapted this Clip model for our task. So this is all for today. Next, we'll learn about the BG Clip.